Hi, welcome to my video on the motion of a particle on a line. In this video, we're going to find the intervals where the velocity and the acceleration are increasing and decreasing. Find the interval where the velocity and the acceleration are increasing and decreasing. So right here we have the s of t, which is the position of a particle on a line, and is represented by this quadratic t squared minus 4t plus 1, where position is the m is for meters, and we have time. So s of t is the position of the particle as time is greater than or equal to 0. Now, the derivative f prime t is the velocity. So the derivative of 2t squared is 2t. Derivative of negative 4t is negative 4. And we have the velocity s prime t is equal to 0. That's where the slope of the tangent is 0, which is maximum minimum points. So we have 2t minus 4 equals 0, 2t equals 4, t equals 2. So if we draw a line that represents the s of t, so we're going to look at the velocity in terms of the time. So the time at 2 seconds. So at 2 seconds, the velocity is 0. And also, we have that at 0 seconds, we have a velocity of 0. So 2 seconds and 0 seconds. So let's look at s prime t, which is greater than 0. So 2t minus 4 is greater than 0. 2t is greater than 4. T is greater than 2. So when t is greater than 2, the velocity is positive, greater than 0. And s prime t is less than 0, where 2t minus 4 is less than 0. 2t is less than 4. T is less than 2. And when less than 2, remember t got to be greater than or equal to 2, so it's from 0, less than t, less than 2 is this interval. So from 0 to 2 seconds, the velocity is negative. And just check that out. You put 1 in here. If you put a 1 in here, you get 2 minus 4 is negative 2, so that's negative. If you put a 3 in here, you get a 6 minus 4 is 2, and that's when it's positive. So this is where the velocity is a negative between 0 and 2, and it's positive between greater than 2. Now let's look at s double prime. S double prime is the acceleration, and we get the derivative of the velocity. So 2t minus 4 derivative is a 2. So we draw a line to represent the, would say, we could put this a vt here, which is velocity. We could put acceleration here, at, so, but that's the s, same as saying the s double prime of t. So the f double prime of t, if we had a 0 here, so what happens, because it's a 2, that means any time greater than 0, the velocity is always positive. Sorry, the acceleration is always positive. So if you put, because it's a constant, so the s double prime of 1 is a 2, s double prime of 4 is a 2, so greater than 0, the acceleration is always positive. So now, if we take the two of these and put them together, I'm putting them together like this. This is s prime t, and below that I'm going to put s double prime t, which is acceleration. So right here we have a 0 and 2, so we have a 0 and a 2, and right here we have just a 0, put the plus. So that means that if right here we have this is a plus. So if this at 2 is a plus, oh, better be careful, minus and a plus, and right here is a plus always to the right of 0, so that's a plus, and that's a plus. So between 0 and 2 is a plus for acceleration, greater than 2 is a plus for acceleration. So if you look at the speed in relation to the velocity, relation to the acceleration, the speed, that's a negative velocity and a positive acceleration. So that comes out to be a negative because the signs are not the same. And the velocity is positive after 2, and after 2 here, the velocity is positive. So 2 of them are positive, so the speed is positive. So that means it's decreasing here and it's increasing here. So it's in this interval from 0 to 2, it's decreasing, and the interval 2 going to infinity, it's increasing. So the interval where it's decreasing is 0 to 2, again because the negative and the positive, and is increasing because both of them are positive. It could also be increasing if both of them are negatives. Okay, that's one example. And let's look at another example. This time we have a cubic. So let's look at, this is st is a position function, and t cubed minus 6t squared plus 16. T is greater than 0, and the position is, notice when the s of t, when t is 0, the object is 16 meters from 0. But let's look at the derivative, which is, again, the velocity. And the derivative is t cubed is 3t squared, and negative 6 times 2 is negative 12, and that's a t, and the derivative of 16 is 0. So that means if we make s prime t equal to 0, we have 3t squared minus 12 equals 0. Factor out the 3t, we get t minus 4 equals 0. So 3t is equal to 0. T minus 4 equals 0. Divide by 3, t is 0. And right here, t is 4. So if we draw this line, and we want to look at s prime t is at, we say this is time, at 0 time, before it starts, the velocity is 0, and at 4 seconds, the velocity is 0. So it stopped. Obviously, if time hasn't started yet, the particle hasn't moved, but at 4 seconds, it's stopped. It means it's going to turn around, whatever. So it's going to the left, it'll go to the right. If it's going to the right, it'll go to the left. So, and if we look at s prime t greater than 0, so that means 3t squared minus 12t is greater than 0. 3t times t minus 4 is greater than 0. So if we look at this, if you take a 5, which is, take a 5 seconds, put a 5 here, you get a plus. Put a 5 here, you get a plus. So 5 is giving us a plus and a plus, which means it's plus, which means it's greater than 0. And 3t minus 12t is less than 0. So 3t minus 4 is less than 0. And I could use it in here too, but if you look at this one, or either which one you look at, if you put the numbers 3 seconds in here, 3 is a positive, so if we take the 3 seconds, you get a, make that a 3, you get a positive, put a 3 in here, you get a negative, so positive times a negative is a negative, which means it's less than 0. So that's the interval where the velocity s prime is positive greater than 4, and it's negative between 0 and 4. So let's look at the s double prime. That's the derivative of s prime. So 3x squared is 3t squared is 6t. Derivative of negative 12t is negative 12. So that's your derivative of your velocity, which is your acceleration, a. So double prime of your position curve is your acceleration, and the prime of your velocity is your acceleration. So if you let your double prime t equal to 0, so 6t minus 12 is equal to 0. 6t is equal to 12, so t is equal to 2. So we look at s double prime, and again s double prime is the velocity, derivative of the velocity and acceleration. So s double prime is the derivative of the velocity or its acceleration. So this is the acceleration, and this happens at 0 seconds. We have at 0 seconds we have no acceleration, and at 2 seconds, so we put 2 in here, put 2 right here. So this is time. So we're putting 2 in. So that means the acceleration is 0 at 2 seconds. And if we look at the s double prime t being greater than 0, 6t minus 12 is greater than 0. 6t is greater than 12. T is greater than 2. So when t is greater than 2, the acceleration is positive. And if s double prime t is less than 0, 6t minus 12 is less than 0, 6t is less than 12, t is less than 2, so that goes 0 less than t less than 2. So between 0 and 2, we have a negative acceleration. So again, what I'm going to do is take the two of these and compare them. We've got the velocity, we have the s double prime, which is the acceleration, and so up here we got a 0 and a 4, and right here we got a 0 and a 2. So let's put that 2 in between here now. Between 2 is in between 0 and 4. So right here between 0 and 4 we got a negative. So right here, so it's a negative in here, and it's a positive here. As for the velocity, and the acceleration is negative between 0 and 2 and positive after that. So that's a negative there and a positive here. But if you compare the two, we put this 2 here, and we put this 4 back right here now. I took it out, but I put all these are critical values. So between right here, it's after 2, it's positive. So between 2 and 4 is positive. After 4 is positive. And in here, this one is, it's negative between 0 and 2, and it's positive after. Oh, it's a negative. I got this double. I got to look at this one. Between 0 and 4 is negative. So this is, again, not to get confused, velocity between 0 and 4 is negative, so it's negative between 0 and 2, and negative between 2 and 4, which is consistent with here. 0 and 4 is negative, so 0 and 4 is negative, and acceleration after 2 is positive. So after 2 is positive. Now, let's look at the speed. The speed is right here between 0 and 2. It's positive. Right here between 2 and 4, it's negative. Right here, greater than 4, it's positive. So it's increasing here. It's decreasing here. And it's increasing. Increasing is INC. Decreasing is DEC. And so increasing, so it's increasing on where the pluses are. So it's increasing. So let's go over here and finalize it. Increasing. So the speed is increasing from 0 to 2 along with 4 to infinity. So it's increasing 0 to 2 and greater than 4. And the speed is decreasing and it's decreasing between 2 and 4. So that's how we find the intervals for increasing and decreasing. Do the S prime, fit the time in, and do the double prime to get the acceleration, fit the time in, compare the two of them, and where we get minuses, plus and minus is negative. If we get 2 minuses or 2 pluses, it's positive. That brings us to the end of the video. And if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye bye.